that making up your own examples is a way to learn. And sometimes it can be homework where all you're doing is looking at examples and making up your own examples. But it's not easy, right? You have to kind of take that notation apart. So the weasel in me would look at that and say, I'm going to make an easy example. They never said that the indexing set has to be uncountable. They never said any of that. They just said every x has to be in that. So if I want to make an interval, like I asked for 0, 1 because I think 0, 1's easy. I'm just going to make 2. A1, A2. For each, so let's check, does it satisfy the no? I have the no in front of me. You should have it in your notebooks, in your paper. So go back to the no. Assume that for each x there is a set. Yeah, for each x, make an x over here. It's inside this one. I can make these close sets. It didn't say they have to overlap. They can't overlap either, right? So I'm just going to make my A1 be 0, 1/2, and my A2 to be 1/2, 1. There you go. And then if I pick any x in the big set, 0, 1, it's going to be in one of these two. And it satisfies, the conclusion is true. So if I take the union of all these guys, 2 of them, I get x. I had a professor who I took a 3rd year of functional analysis with. I thought the world of him. I'd come in and I'd have everything ready to go, theorems all proved, present the theorems, and he would just ask me, can you give me an example of that? Like, no, I didn't prepare that. And so he'd say, well, you're going to have to give me an example of that. Then I come in with the example prepared of all the, all the word definitions, theorems, and he'd ask me, if I weaken that hypothesis and change that from differentiable to continuous, can you give me an example where it doesn't work? I can't. And so I'd go back, and then I started to learn, like, okay, when I have a theorem, I'm going to have to weaken some things and see why it doesn't work. Like, I have to tinker with that thing for a while. So we'll do some of that in here built into the course, but that's part of, like, proofwriting is to really understand your theorem and what it's saying. So I think a good question would be, what if that collection's not just subsets? Does it still hold? Like, you can start making up counterexamples if you start weakening any one of the no's, taking it away and removing them. Right? You can start, that's my pooching out example. Somebody actually said it in class, like you were saying, Sebastian was saying, okay, you actually need that condition. So each one of these conditions are important, and when you start tinkering with them with examples, you start understanding why they're in place. And it helps you write your proof. But it's also like, when you write a proof, you have to fully understand what you're doing. And if you can't make an example, that's what he was pointing out. You really didn't know it. Yes, you wrote me a nice clean proof, but you really don't know it because you can't tell me what happens when I weakened one of the conditions. You don't really know why that condition's there, is what he was trying to tell me. I also made him mad because I went to Game 5 of the National Championship Series, Braves against the Pittsburgh Pirates, and I thought that was a valid excuse to not be prepared the next day. I had 3rd row seats. I came in and I was all excited. I said, 3rd row seats. I saw Barry Bonds right up there. I saw Deion Sanders. Like, I was right there. And he's like, I don't care. Okay? Not an excuse. Okay, let's go through the list of know and show on your boards. So we had a couple conditions. We know it's a collection of subsets. The subset piece is really important, as we saw, like my counterexample of why the first example I would make is these windows. I think somebody else had windows too. You had windows, right? It's like if you have windows and you go minus 0.01 to plus your endpoint plus 0.01 plus your endpoint, you'll get pooching out over the side of the thing. You won't get exactly equals x. So that subset one is really important. And for every x, I can find an element in that collection of subsets so that that x is inside an ax, kind of like I made with my example. That's my no. The show, I'm glad you wrote it. I didn't ask you to, but you wrote what we have to show, what we want to show, because we want to show that the union of all these guys becomes x. And when we have two sets are equal, it means we have two proofs. I just told foundations that when you got equal, you have to show something equal, it's bad news because you have to do two proofs. All right, so let's go for it. That direction. Let my y be in that. Foundations, they're just starting this. Hopefully I don't accidentally give them one of your homework problems. It might happen. By definition of union, y belongs to a x, I'm abusing again, for some x belong to x. There's a lot of x's. So bad habit of mathematicians is to abuse letters. I'm abusing them really drastically. Variable abuse. Because the x that was in the definition, in the theorem statement is a variable, and now I'm using x as a fixed thing, and I shouldn't do that. But if I start using alphas or something else, I might start mixing up alphas and x's in class. So I won't change it, but I'll just beat myself a little bit in front of you and tell you that I shouldn't be doing that. It's a boring proof, but I think in foundations I would have told them I need to show if y belongs to this side, then y belongs to this side right at the beginning, so my reader knows that. I would probably be directing the reader a little bit more, but I said it at the end. By definition of set containment, since I have y belongs to this side and y belongs to this side, so I have set containment in this direction.
So for this one, we already know that a sub x is a subset of x by our no.
No, right there, she has it.
Right.
C is a collection of subsets in ax, so ax belongs to C, so therefore ax is a subset.
Okay.
So that's really important. This is what AJ was complaining about. Like he said his proofs were the same as his friend's proofs. If you haven't used your hypothesis in your proof somewhere, if you didn't need it, Fred Andrew was his name. Fred Andrew would ask you, give me an example of why you needed that particular hypothesis from no. Collection of subsets of X. So there it is. Your no's got to show up in your proof. If they didn't, something either is wrong in the proof statement, which this is your book is a cooked book. Like everything in there should be doable, right? There are things that are not doable, like when you get higher up to classes, they might give you something that's not true in the book to prove, like stuff like that. But here, everything is going to be cooked. It's an undergraduate book. And so it's unlikely they gave you something in the hypothesis you don't use. So if you didn't use the hypothesis, it's a red flag that something went wrong. You can put in your notebook, I didn't use the hypothesis, ma'am, I don't know what happened. It's fine, it happens. I was actually a fourth year graduate student when I had Fred Andrew like that one-on-one. So I wasn't doing the examples in my fourth year, so it can happen. Okay, other direction. Oh, we'll use blue now. I do like the colors, that we can use different colors, but you don't have different colors, especially Nakul doesn't have different colors because he has a tiny notebook and one pen.
Yeah, what about blue pen?
I think you should still keep it.
So, this direction, let y be an element of x. Here I'm good, foundations, level, fundamentals, we must show y belongs to that union. I think that's the difference between Dr. Clark and I. I don't want to show, I just have to show it because it was in the book and they made me. If y belongs to x, then I can write it this way. Contain that collection. I'm highlighting for my reader that AY is an element of that collection. I shouldn't have used Y's either. Let me continue to abuse the X. Pretty straightforward, boring proof. All right, you have varying degrees of experience in the class. I'm gonna recommend you review page 13 to 21. This book is not bad to read. This is one of the, I just love when this book came out.